Hi everyone, this is a thesis by Deepak Shaju, student number 8079559, about the performance and behavior of fiber-reinforced geopolymer concrete column that is subject to various load conditions. As you see on the background is the world's first building that has been constructed with geopolymer in Queensland. Moving on to the overview, today we'll be discussing about the introduction, objective, research question, types of polymer that has been used, the mechanical properties, literature review, research design test, conclusion, and reference. Moving on to the introduction. What is the need for an alternative for cement-based concrete? To reduce the carbon emission, to improve the chemical resistance, to increase the compressive strength, to reduce the energy consumption, and to make a greener material in construction. The demand for sustainable building material is increasing day by day. In fiber reinforcement concrete, we use aluminum silicate instead of cement. The main objective of this thesis is to replace the OPC concrete with fiber reinforced geopolymer concrete. This fiber material is a waste material that can be reused and recycled, and it is a high property, mechanical property, and durability in concrete. We will study about the behavior and the various load conditions. The reaction, load bearing capacity, and the deflection is also being studied in the thesis. Moving on to the research question, the performance and behavior of fiber reinforced geopolymer concrete subject to various load conditions. The stress-strain relationship, behavior under various load conditions, increasing the static and dynamic tensile strength, increasing the fatigue, increasing the ductility, the compressive strength, and fire resistance is also being studied. What are the various types of polymer fiber? Carbon fiber, glass fiber, metal fiber, basalt fiber are some of the polymer fibers. Carbon fibers is composed of carbon atoms with 5 to 10 micrometer in diameter, having a high compressive strength, low weight, and high heat resistance and high tensile strength. Glass fiber, whereas 200 to 400 filaments, has high strong bonding capacity. The metal fiber the steel is now normally cheaper and high increase in ductility, the resistant to fatigue, blast, impact, etc. Basalt fiber with 15 to 20% higher tensile strength and modulus it can be used in chemical environment friendliness. Moving on to the mechanical property in literature review that has been discussed. The modulus of elasticity increases with fiber content increases. The compressive strength increases from 0 to 50%. The flexure by adding 4.55% of fiber increases 2.5 times. The toughness increases 15 to 14 times than OPC. The fatigue strength increases by 70% for the reversal load. The impact resistance increases from 5 to 10 times than OPC. And also the fire and corrosion resistance also increases. As you see on the graph, shows the OPC concrete and geopolymer concrete based on the property with the curing days that has been mentioned. The literature review that we studied shows the increase in compressive strength, ductility, fire resistance, and the improvement in the energy absorption capacity, ductility. As you see in the figure is the loading that has been done in a geopolymer concrete column under various steps. The research design studies about the behavior of geopolymer concrete under various axial load and without polymer confined studies. The stress strain behavior has been studied in this. As you see in the figure, the uniaxial response and the flexural response of the normal concrete and the FRC concrete is shown. Various tests has been conducted to geopolymer concrete. They are static tests to know the mechanical property of the structure, the third point loading composite prism test to find the ductility of the concrete, the pull-out test in which 7 to 16% increase in the strength for normal fibers and 18% in steel fibers, the uniaxial tension and compression test, the slump test to measure the workability, the cube test to evaluate the compressive strength, the creep and spaling test to find the fire resistance. So we concluded as the addition of fiber significantly increases the load bearing capacity and the ductility of the axial compression. Addition of FRC material increases the compressive strength by an average of 50%. There is an increase in static and dynamic property. The flexure and high ductility is also being observed. The strain gauges, accelerometer, and the tiltmeter can be used in assessing the deformation, vibration, alignment, and load distribution. Environmental factors such as temperature, humidity is also a factor. In the table shows various fibers being uh, experimented and the compressive strength, the splitting tensile strength, and the flexure strength being shown. These are the references that have been used for this thesis. Thank you.